Okay, hello there. This is Physics 10 from the subtopic of time. Specifically, I'm looking at the ticker tape timer today. It's all about paper and pen, baby. Just paper and pen. As long as you can see, you can assimilate. So, a ticker tape timer is an electric device that vibrates at a constant speed of one cycle or beat every 0.1 second. Okay, every 0.1 second. Therefore, it vibrates very fast. It is a pin that hammers on carbon paper, and under the carbon paper is a paper ribbon whose end is attached to an object that is about to be allowed to fall down or to accelerate. The object is allowed to accelerate or move under gravity or in linear motion, therefore, and without falling under gravity, and the state of the motion is concluded by observing the spacing between the dots created on the paper ribbon. Therefore, as the paper ribbon is being pulled under the tape, under the ticker tape, the ticking, it ticks, and then it has a tape that runs through it. Therefore, ticker tape timer. It's a timer because it vibrates at constant speed of 1 beat every 0.1 seconds. Therefore, you can interpret the motion or make conclusion or just study the motion by looking at the dots created on the paper ribbon. Remember, it has got carbon, then paper ribbon that passes under the carbon. So an example here is we've got three paper ribbons there, and there's X, Y, and Z or Z. X, you can tell that these I tried by all means to show that they are evenly spaced. Here the spacing is increasing from this point to that point, then here the spacing is reducing from that point to that point. So the starting point is here. Okay, the starting point is this one. So if this was the starting point, it means the second point was this one, then the other point, the next point was this, the third point for all of them. The first points were these. Direction of motion is in that direction. You may not always be given these arrows. Okay, you may just be given the starting point, then you have to interpret. Okay, so it means after this point was made, the tape was pulled in that direction, this arrow's direction, and then a second point was made. Okay, so interpreting these dots here, I would say here speed was constant. Okay, so a ticker tape timer allows us to study speeds that are very fast. Okay, speeds at high speeds, let me just say, so high speeds. So speed is constant, the body was accelerating, meaning speed was increasing. You can tell by the dots that are created here. At first the dots are close to each other, and then the dots begin to get spaced, meaning the paper began moving at a much faster rate. That is the reason why the dots are spaced like that. Then here the body was decelerating, meaning that the first dot was here, second one, then the more the dots become close to each other, the slower the speed, meaning that if the object stops, finally the dots will not be spaced like this. The hammering will just be on the same point. I can compare this to a car that is having a leakage in its oil. When the car is moving at high speed, then begins to slow down, like in this third Z paper ribbon, the dots will behave like this, will be dotted like this. Finally, when the car stops, the oil will accumulate just on one spot like that, on one part like that. So you have to be able to interpret the dots after being given the starting point. Not that given the distance between dots at constant speed, the speed can be calculated using the formula. Okay, the distance in meters, time between dots is always 0.1 seconds. Okay, time between dots is always 0.1. Distance, of course, is in meters. Time is in SI units, which is seconds. So allow me to do a question here to simply try and apply what I'm just from explaining. A paper ribbon obtained from a ticker tape timer, 6 evenly spaced dots. A paper ribbon obtained from a ticker timer has 6 evenly spaced dots. Even meaning the same. Calculate the average speed if distance between the dots is 1.2 centimeters. Okay, so that's our paper. It's torn here, the paper ribbon. These are evenly made dots. So speed is equal to distance over time. Maybe I should have even written this one. Oh, it's actually here. Distance over time. How do you measure the distance? You simply look at the spaces in between the dots, okay? Because this is the first dot in this diagram, and that's your your last dot right there. So if this is the first one, then the distance is from here up to there. And we've been told that the dots are evenly, meaning they have the same distance in between each of them. And then we're told that the distance in between here is 1.2 centimeters. So this is 1.2, 1.2, 1.2, 1.2, 1.2. So 1, 2, 3, 4, 5 times 1.2 is the total distance from here to there. So 1.2 times 5 over 100. Why am I dividing over 100? I'm converting to meters. And then my final answers will simply be as shown here. My distance will be this, and then time t. Remember that the timer creates a dot every 0.1 seconds. So this is 0.1, 0.1, 0.1, 0.1, 0.5, 1. So I simply multiply by 5 because each space again represents 0.1. Remember that the space, even if it is small like this one or like that, the time in between the dots is 0.1 because the timer vibrates at constant speed. Where is that? An electric device that vibrates at constant speed of 1 cycle or 1 beat, 1 tick every 0.1 second. So it doesn't matter how they are spaced. The time in between every hammering, every ticking is 0.1 seconds. So I simply get my time, the time taken for these dots to be made by 0.1 times the spaces in between these dots. So finally, I do my calculations here and my answer comes out as 12. What? Who's this guy? Okay, an ant just crossed my paper there. Therefore, my answer is 0.12 meters per second. That's my answer right there. You can prove it. Question 2. 9 dots were made by a ticker tape timer on a paper ribbon attached to an accelerating toy car. Calculate the distance between the dots in the paper ribbon given that the speed of the toy car is 0.47 meters per second. So distance, you simply do your formula, right? Always write your formula first. So this is our speed we've been told. Then 0.8 seconds, how did we find that one? We simply multiply the spaces 1, 2, 3, 4, 5, 6, 7, 8 by the time. Okay, so our time is 0.8. So when you do mathematics here, the answer, the distance comes out as 0.376 meters. Okay, calculate the distance between dots in the paper. So our ultimate distance is 0.376. That's the distance, but this is not the distance between each dots. This is the distance from this point here to that point there. So I think you finish this one for me. So you simply say the final distance between dots. The distance between dots is going to be 0.376 over 8 because there are 8 spaces. These are the distances we're talking about. So you simply divide by 8 and you have your answer in meters since we have not changed anything there. Okay, so I think I didn't finish that. You finished that for me. There is I was just trying to draw it. A toy car, velocity moving in that direction, paper ribbon, row there, then the ticker tape timer. It's an electric device. There should be an electric cable running from the timer there. So our last question there is study the paper ribbon below. Last dot, object motion. Okay, this object was moving in that direction and this was the last dot, meaning this was the first dot. So as the object was moving, the dots began increasing. Okay, the distance between dots began increasing, meaning the object was accelerating. Calculate the rate of change of velocity if the object's velocity was 0.94 by the time the last dot was made. This is your final velocity. Initial velocity is always 0. Of course, it's always 0 when the body is from rest. Maybe I didn't just include this one here, but it's always 0 when the body is from rest. So you use this formula because it's still linear motion. So acceleration is what we're looking for because we can tell to say the body was accelerating. Final is this. Initial is at time. Remember, you just count the dots and then multiply by 0.1. Count the spaces between the dots and then multiply by how many those spaces are. So our final answer is 1.34 meters per second squared. Hope this was helpful to you. Remember to subscribe and leave your comments. Bye bye for now.